All right, today we're going to talk about some basic information on graphs. So the first thing I want you to know is that graphs is just a way to visually represent our data. We can have tables and we can have spreadsheets, but a lot of times it's a lot easier to see patterns and trends and relationships if we visualize that data in the form of a graph. In our class, we are going to spend a lot of time looking at line graphs. We'll also create some scatter plots in some of our labs where you're going to just put all of the data down and then give a best fit line so that we can see kind of overall what that relationship or connection is. We'll talk about those more as we get into some specifics throughout the semester. When you are responsible for creating your own graph in a lab assignment, you will be given some blank graph space, and you will need to decide all of the labels, numbers, values, any information that needs to be represented on that graph, you're going to have to put it on the paper. So it says here that it will be your responsibility to scale those values so that you get a nice large graph. And what we mean by that is however much space I give you for your graph, on the x-axis, whatever values you put on the x-axis, you're going to need to look and see your range of numbers and then decide how you want to number that x-axis. We want to make sure that the points that we're going to plot use at least half of the axis. So are you going to make your scale go from 0 to 10? Or does your scale need to go from 0 to 50 or maybe from 0 to 100? Our y-axis also needs to be scaled, but it's going to be specific to the values that belong on the y-axis only. So in other words, however you chose to scale your x-axis is not going to determine your y-axis. It's a different variable on the y-axis, and you most likely have a different set of numbers. So maybe your x-axis will go from 0 to 10. Maybe your y-axis will go from 0 to 80. So you will need to make that decision on your own, but we want to make sure that you cover at least half of the graphing space. If this is a lab assignment where your graph, of course, is going to then be graded, you will lose points if your data only takes up half or less than half of the graph. We're going to do a lot of analyzing slope values and y values when we do look at graphs, but for today's lesson, we're really just going to focus on the slope. I have down here a few different interpretations of what slope is. So I've got these arrows here, and then next to it I've got the words rise and run. A lot of times, I know when I was in school, my math teacher would say that the slope is rise over run. And I use that phrase a lot too because I feel like it's pretty basic. And so most kids can follow that pretty easily. If you look at the arrows though, I have just an arrow pointing up, which would indicate an increase in value or that we're moving literally vertically upward on the y-axis because our value is rising. Technically though, that could be a rise or a fall. We could have an increase or a decrease on the y-axis, but the phrase we normally say is rise, so that's why my arrow is only pointing up. The run is going to be our change in the value along the x-axis. Now, for most of our graph, that x-axis is going to end up being time, and so we will only read it moving from 0 and then moving it in the positive number direction, so to the right. So that really won't change much. If you are in math class and you're given a slope formula, there's a couple of equations that we could get, but most likely it was introduced to you as y2 minus y1 over x2 minus x1. What I want you to understand from that is that we are going to continue to use this same main idea as to what slope is, but in our class, we're not going to use y2 and y1. For today, this formula works perfect because we're just going to look at some random numbers on a graph and we're just pulling the numbers off. But in the future, these are going to be variables. And so instead of saying y2 minus y1, we're going to say final minus initial. So if my graph is showing distance on the y-axis, this would be my final location. And this would be my initial location. So the change in my position would be point B minus point A, my final position minus my initial position. On the x-axis, it works the same way. This would be data point B, and this would be data point A. So go ahead and program your brain now. Instead of saying y2 minus y1, we're going to want to say final minus initial. Here we're just going to talk about the basic labels that need to go on the graph and what the different parts represent. Our x-axis is going to represent our independent variable. So this is often the thing that we're going to manipulate as part of our setup. For us though, a lot of times it's really just time. And I want to point out here, not only does it just say time, but it also gives me my unit. All of your labels will need to have the variable and the unit that corresponds to that variable. The y-axis is going to be our dependent variable. This is typically the data that you are collecting. We are looking to see if and how this number changes throughout our experiment. And it is also going to have a variable title, so in this case it's distance, and a unit. We like to talk in inches and feet, miles, yards in this class, in the United States, but in this class we're going to want everything to be in meters, so it's important that you tell me the units as well. This line right here represents my slope, and so if we are talking about slope, this is going to give us our relationship. Now, how we interpret or describe the slope kind of depends on if we're in a math class or if we are in a science class. In math class, we're going to see things like positive and negative slopes because our numbers will come out to be positive and negative numbers. In our class, we're going to continue to use those labels, but we're also going to use words like direct and inverse in order to describe the relationship between the variables located on the x and the y-axis. Here we're just kind of reviewing. If we were in math class, this would be a positive slope. I don't have numbers on the graph, but let's say that this went from 0 to 10 on the y-axis. My slope equation says that we're going to do y2 minus y1 over x2 minus x1. So if I just look at this numerator here, my final or second position would be a value of 10, and my initial or first position would be a value of 0. So my format says that I'm going to do final minus initial, so 10 minus 0, which gives me some positive number here in my numerator. If I look at this slope, we would describe this as negative because once again, we're just filling in what those values would be. So final position B minus initial position A. Here, my formula would have me plug in 0 minus 10, which means that this is going to end up as some negative number in my math work. So this is why we would call this a negative slope. In science, we're going to learn that this is also described as a direct relationship or an inverse relationship, but we'll get into that later. Here, we are going to practice saying that my slope value here is 0. When we put vocabulary words on the graph, this is going to be really important that we say our answer is 0. Yes, we could say that the y value does not change because my slope is the change in y-axis over the change in x-axis. It would be correct to say the y value is constant, but again, our conversation right now is about the slope, and so in that case, we are going to say we have a slope value of 0. And then I just wanted to take a moment to just kind of summarize, how do we know that something is a constant slope? It is a constant slope if we can take our pen or pencil, lay it down one time on the desk, and have it cover the entire graph. If I were to take this line, or if it were my pencil, and I were to try to lay it down over this graph, I can lay it down one time, and it covers the whole graph. So that's how we know that the slope value... Sorry about that. That's how we know that the slope value is constant. I also want to point out what it says here. The y value does not have to begin at a value of 0. Be really careful when you're answering questions for me in the future. You always want to make time to carefully look at the graph. Here, my graph on the left has a value of 0 way down here at the axis. This particular graph does not start at 0. Now, I know there are no numbers on this, so let me just throw some numbers on the screen. Hypothetically, if this were a 2 and this ended at an 8, my change in y value, my numerator on my slope equation, would not be an 8, although there are several kids on a quiz or a test that would completely say 8 because they just looked at that final value and they didn't carefully look at both points. Because it started at 2 and then rose to 8, my change in y-axis should just be a 6, not an 8. So be careful with that, okay? And then down here at the bottom, it says that we want you to interpret this bottom line here, or this slope right here. Yes, technically, that is a constant slope, but what I'm going to want you to be looking for, if it's a multiple choice question or if it's a free response question, what I'm going to want you to give me as the right answer is that we have a slope value of 0 here, okay? You are not wrong. It is technically a constant slope, but the better answer is that there is no slope. I mean, really, how do you say that something doesn't exist? Is constant, right? When I say it like that, then it kind of makes sense that our preferred answer is going to be that our slope value is 0, okay? All right, a couple more things that I wanted to go over with before we're done today. This would be a changing slope. How am I supposed to know that? Well, in general, if I were to take my pencil, lay it on my desk, and then try to set it down so that it covers the graph, I might be able to cover parts of the graph, but I'm definitely going to have to take my pencil and I'm going to have to do some tilting and turning in order to try to get that pencil to cover my graph completely, right? So if we have to make changes to how our pencil is laying on our desk, then it's a changing slope. At its least simplest interpretation, that is what I want you to know. If we are being more specific, I do want you to know that this is a changing slope. Specifically, it's increasing. So again, we don't have any values initially on this graph, so I just kind of hand wrote some in for you. But what I want you to see is that if we were to do our slope formula, where it is our change in y value over our change in x value, we're going to be putting in numbers here for this first section of a 0 and a 0.5. So 0.5 minus 0 over 1 minus 0, because we're going to go from 0 to 1 right here. This is going to give me 0.5 over 1. So that's just going to be 0.5. So my slope here would be 0.5. If I look at the next segment, we're going to go from 0.5, and we'll just round this to 2 to make life easier. So if we go from 0.5 to 2, then that is going to give me 1.5 over 1. So this would be a slope value of 1.5. So we can see that the slopes are indeed changing, so that tells me that it's not a constant slope. We can also see that these values are getting larger, which is why we specifically call it an increasing slope, okay? And then if we look at this graph here, it's the same idea. You might be able to visually see that the steeper my slope was, the greater my slope value, or maybe we already know that from math class. So if we look here, we might say that we started off steep and then it kind of flattened out. Or maybe you are a person that needs to put those numbers in. Go ahead and do that slope formula, plug numbers in from the graph. What we're going to find is that this part of the graph has a slope value of 10. This next segment has a slope value of 3.5, and then here we have a slope value of 1.5. So simple information, I need you to know that it's changing, not a constant slope. Make it a little bit more detailed in your response there and tell me specifically the slope value decreases. All right, the last thing that I want to talk to you about here is what do we do if we're being asked to describe a graph like this? Well, if the question does not tell you specifically what part of the graph, then it's asking you about the graph as a whole. Well, the graph as a whole is changing. As a whole, this graph is changing because I got different tilts going on for sure. Typically, what we would do here is we would ask you about the graph in parts. So we should be able to see that we clearly have a constant positive slope here for this portion of the graph. We then have a second or additional slope value here, which remember my best answer here is that my slope value is 0. And then I have a third slope value, and this, whatever that number comes out to be, is going to be a negative number. Okay, so real basic information about graphing. When we get more vocabulary, then we'll start revisiting these graphs and we'll turn them into more challenging questions. But for right now, can we simply interpret whether it is a changing or a constant slope, and then whether or not it is positive, 0, or negative for that slope value?